Okay, good morning still, and thank you all for coming. My name is Brian Day, and I am from NASA's Solar System Exploration Research Virtual Institute. I know that is way too long a name. Oftentimes we just call it NASA Survey. But one of the things that I get to do there is I get to work with a brilliant team of engineers at NASA's Jet Propulsion Laboratory down in Pasadena. And we have this wonderful set of data visualization and analysis portals. These are online portals that allow you to view the surfaces of other worlds as seen through the eyes of many different instruments aboard many different spacecraft. Now, these portals are being used for a variety of things. They're being used for mission planning. They're being used for planetary science, but it turns out they're excellent tools to use for the general public. And so we've made essentially a subset of this available to anyone to be able to explore the solar system. You don't need to buy anything. You don't install anything. You just point your browser to trek.nasa.gov. And when you do so, you'll get a list of worlds, a growing list of worlds that you can explore. And so what I'd like to do is take you on a little bit of a guided tour of the solar system today using the solar system treks and show you how you can start conducting your own explorations at home. And also, as we have upcoming missions, how you can essentially follow along using these portals. So we'll start out with the moon. Our moon trek portal is basically how we got started. And like any good GIS system, you can zoom, you can pan, and what we'll do is we'll pan down here to a crater. This is called Tycho crater. And it's a pretty interesting looking crater. And one of the first things you might want to know is, well, how big is it? And that's actually very simple to determine. You can just draw a line across it, and it'll tell you 83 kilometers across. That's a big hole in the ground. The next thing you might want to know is, well, how deep is it? Well, that's also very easy to tell. You can simply, again, we'll draw a line. We'll extend it a little on either side now so we capture the rim. And we can generate an elevation profile. So we can measure here very easily the heights of mountains, the depths of craters and valleys. Pretty cool. It allows you to do some neat exploration right there. Now, another thing you can do is you can draw a box around any piece of terrain you want. So we'll draw a bounding box around Tycho here. And you get an option of generating an STL or OBJ file that you can send to your 3D printer, and you can make 3D prints of any terrain you like on the moon. Another fun thing you can do is you can draw a path with your mouse. Just draw a path anywhere you want, and the portal will return to you a QR code. Scan that QR code into your smartphone. Put your smartphone in a pair of $5 Google Cardboard compatible goggles. Whatever path you drew, you will now be able to fly in virtual reality. This is kind of fun. So you can create your own customized virtual reality experiences. Now, another thing you can do is you can put it into interactive 3D mode, and you can interactively just start flying across the surface of the moon. You can fly down into craters. You can do you can zip along the surface. Just using standard keyboard game control keys and your mouse, you can really just have a lot of fun going exploring. So, there's a really good opportunity to put all this technology to use, because coming up here, we've got a series of missions to the moon. Between 2022 and 2025, we have scheduled 10 robotic missions to the surface of the moon. We are also planning at this point in 2025 to be landing the first woman and next man on the surface of the moon. We're also going to be flying the first person of color to the moon. About time. This is the Artemis program. Artemis in mythology was the twin sister of Apollo, and she was the goddess of the moon. But right now, you can get a preview of where we're going. And where we want to send people is to the South Pole of the moon. And the reason is because at the South Pole of the moon, unlike, say the equator of the moon, where the sunlight can shine straight in, at the South Pole, the sunlight is just skimming horizontally across the ground. And so any crater at the South Pole, sunlight will just go across the top of it. And any rim around that crater will create a shadow. There are craters at the poles of the moon who are permanently shadowed. Their floors have not seen sunlight in billions of years. Because of that, they are really, really cold. They're the coldest places we've measured anywhere in the solar system, even colder than the surface of Pluto. And because they are so very cold, we've discovered that in some of these deep shadows, water ice can accumulate. That's important. Water ice will be a key resource for us when we end up living and working on the moon. You need water to drink, but you can also break the hydrogen and oxygen apart in that water. The hydrogen you can use as fuel. The oxygen, well, breathing is something you'll probably really, really, really want to do if you're living and working on the moon. But these shadows, as you can see, they're deep, and it makes it hard to plan a traverse. But if we switch our view to a laser altimetry view, bouncing a laser down from a spacecraft and precisely measuring the amount of time it takes it to bounce back, and thereby measuring all the ups and downs very carefully, we can pierce those shadows, and we can figure out the details of all this really interesting terrain. Yes? I will show you. We will do that. So here, you can also do a slope map. This is useful if you are planning to figure out a traverse path for a rover to get to one of these permanently shadowed regions where you might have water. We can overlay the actual permanent shadows onto that and start seeing. So red is areas where you probably wouldn't want to drive a rover. Blue is safe, and so you can start figuring out maybe where good approach paths are to some of these permanent shadows. We can look at temperature maps, maps of average temperature and maximum temperature. Again, figuring out where our resources of ice might be. We can even look for deposits of surface frost, or use a neutron spectrometer to sniff out where hydrogen is. And hydrogen is probably going to come in the form of some kind of compound, and one of the most common compounds for it is going to be water, H2O. And here we have a map showing ice stability at depth. How far down do you have to dig to get to a temperature where ice would remain stable? And in those permanent shadows, you don't have to dig at all. It's stable right on the surface. Locus Mortis is an area that we're going to be landing with a robot probe. You'll be hearing this next year is when we're planning to make this landing. It's up in the northeast portion of the visible side of the moon. And a lot of interesting geology going on here. You can see lots of fractures across the surface of this big plain here. And we're planning to land right about in here at this point. Dorsum Arduino is also a place we're looking to land next year with a robotic probe. And you can see this kind of interesting compressional ridge where the ground has buckled up. Lunar swirls are really interesting things. So the moon does not have a global magnetic field the way the Earth does. But it does have a localized magnetic field. Areas where, just in limited areas, there's magnetic fields. And in many of those cases, you have what we call lunar swirls. These strange patterns, sinuous patterns of light and dark. It almost looks like, if you think of like putting a bar magnet under a piece of paper and then sprinkling the iron filings over it, you can start seeing these traces of magnetic field lines. Another place we're going to be going very soon is Mare Crisium. We'll be sending a probe, a robotic probe to land there, probably in 23. And on the far side of the moon, we're going to go to the Schrödinger Basin. And this is a fascinating area. One of the things you can see, again, a lot of fractures where magma came up from beneath the crust, made its way through fractures in the crust and wedged those areas apart, forming these valleys here called Graben. And you can see in one place, lava actually erupted through one of those. You can see a volcanic pit here with a dark ash deposit around it. Now, most volcanoes on the moon are very inconspicuous things. If you look very carefully, you'll see some very low pancake-like features here with craters on the top. They barely show up at all. That's because lunar lava tends to be very thin, runny stuff. It has very low silica content. It means it has very low viscosity, about the viscosity of olive oil at room temperature. It's hard to build a mountain out of that. So most lunar volcanoes are not really spectacular. They're hard to see. But then there are these guys. These are the Gruithuysen domes. And they just stand right out. These are made of thick, pasty, silicic lava. What we would here on Earth probably refer to as andesite. And we look at this and we go, why would the lava here be so very different? And we don't know. That's one of the reasons why we want to go here and explore. We also have a portal for the moon, for Mars, the Mars Trek portal. And here you see Mars as you would see Mars if you were just looking out the window of an orbiting spacecraft. Mars today is a complete desert. You will find no liquid water anywhere on the surface. There are some tantalizing hints that there might be some liquid water flowing beneath the surface, but nothing on the surface at all. But we now realize that that wasn't always the case. If we switch to a laser altimetry view and color code it so that blue is low, orange higher, we get something like this. And we can see evidence of ancient river channels, dry riverbeds now, but showing where water once flowed across the surface of Mars and flowed into what was a large bay opening up into a great northern ocean on Mars. Mars was once a wet place with water flowing across its surface. That gets our attention. Because here on Earth, wherever we find liquid water, we find life. Even if it's in the boiling pools of Yellowstone National Park, even if it's beneath the frozen ice cap of Antarctica, even if it's in the cooling system of a nuclear reactor, wherever we find liquid water, we find life. And so if Mars was once covered with liquid water flowing across its surface, that gets us interested. Looking at this in greater detail, zooming down, you can see how the water carved and streamlined the terrain. It's not hard to visualize here how the water flowed from left to right. Now, one of the sites of former water that is really interesting us today is a place called Jezero Crater. And Jezero Crater was once a crater lake. It was a place where water flowed in through channels to the west and the north into this crater that is now largely inundated, but it filled this with the water into a crater lake. We can see an outflow channel here coming out to the northeast. We can imagine what this looked like some 4 billion years ago. Water coming from an extremely large watershed to the west, coming in, flowing into this lake, and concentrating. And as water flowed in, it dropped its sediment load into what we would call a delta deposit. And so here, using this, we've got a generalized map here of Jezero Crater, the western inflow channel, northern inflow channel, outflow channel. This is the landing ellipse where our Perseverance lander targeted. So here on Earth, we see these delta deposits. Again, here's the Nile flowing into the Mediterranean. And similarly, here's that inflow channel and the delta deposit that it left as the river entered through this breach in the crater wall and entered into the lake. As the water slowed, it dropped its deposit of mud and sand and silt, but that had been gathered from across a vast watershed, brought in and concentrated right here, at a time when Mars was at its most habitable. So this is the kind of mud pile we want to go digging in. If we want to see signs of perhaps past life on Mars, this is where it might be concentrated. So let's zoom in to the Perseverance landing site. So there's Jezero Crater with the landing site marked. We'll zoom in closer. We'll zoom in closer still. And closer. Now we're starting to see some of the sand dunes that the spacecraft was smart enough to avoid. Zooming in, we can get down both on the Moon and Mars to sub-meter resolution.
Do you know any cool latitudes or longitudes of past missions that have remnants of past missions?
Oh yeah, you can go to mission sites using the tracks. They're marked there. Yeah. Yep. Mm-hmm. And so here we are looking at the landing site in Jezero Crater. Looking out into the distance here, these ledges are the actual delta deposit. The mountains you see in the distance are the actual crater rim of Jezero Crater. Moving ahead here, we can look at the actual sedimentary layers that the deposit or that the rover is going to be exploring. So you can see these nice sedimentary layers in the delta deposit. And so this is where our rover is planning to go. So again, you can get a preview of what's coming up in this mission, and as the rover starts going along, you can follow along here. This is the breach in the crater wall where the river flowed in. And then we can actually go outside the crater and follow the river channel as it made its way toward the great crater lake of Jezero. Mars has a bunch of other interesting topography too. This is Valles Marineris, Mars's Grand Canyon. And when I say grand, I mean really grand. If it was placed here on Earth, it would stretch from Los Angeles to New York. Its walls are 8,000 meters tall as the Himalayas, the tallest mountains here on Earth. And coming down from these walls, we have titanic landslides. Like the Grand Canyon here, Valles Marineris is actually a complex network of canyons. And here we'll use the ability to fly. We'll fly down into Valles Marineris. And you see we're flying over sand dunes, and now these sedimentary deposits that were laid down on the floors of ancient paleo lakes long ago when this canyon was filled with water. It's fun to just go fly. In fact, one of the things I was just doing in the expo there, I was taking kids along. We were flying up and down this canyon, just interactively, just having fun. Mars has volcanoes, and I mean big volcanoes. The biggest volcanoes we've found anywhere in the solar system. Here we have a group of volcanoes known as the Tharsis volcanoes. And Olympus Mons is certainly the giant of the family. Here you can see it stands, over 20 kilometers tall. Wow. Much higher, almost 3 times higher than Mount Everest. And look at these gigantic flows extending out around the edges here. Using laser altimetry, they really pop out into view. We can take, so here's a view through the Viking orbiter camera, and we can use in Mars Trek, we can actually pick any country or any state we want, and we can overlay it onto terrain. So here's Washington State. Now think about it. You've all seen pictures probably of Mount Rainier, that gorgeous, beautiful, giant volcano, the tallest volcano of the Cascade Range up in Washington State. It's a beautiful, gigantic mountain. But when you look at a map of Washington State, Mount Rainier is but a dot on that map. As you can see here, Olympus Mons is bigger than the entire state of Washington. This is really, they do things on a really dramatically big scale on Mars. Here we're zooming into the volcanic caldera on top of the volcano. If you've been to Hawaii, you could put the entire island of Oahu into this crater. You can see it's a very low, broad profile. We call this a shield volcano. But that group, the Tharsis group, is not the only group. There are other groups of volcanoes, such as the Elysium volcanoes. And south of the Elysium volcanoes, we find this area, the Cerberus Fosse. Now, a few years back, we had a mission launch from very near here, the Mars InSight mission. And InSight was a robot geologist, and it took along with it a seismometer. Landing on Mars, InSight has since discovered that this area right here, the Cerberus Fosse, is an active seismic area on Mars. There are Marsquakes being generated here as we talk. It's really spectacular terrain. The crust is torn apart in very spectacular ways. And again, you can fly through these cracks using the Mars Trek portal. Also, in the Cerberus Fosse area, we see this one crack surrounded by this interesting dark deposit here. This is a volcanic ash deposit. Now, many of the volcanoes that we see on Mars are billions of years old. And that led people to think that perhaps volcanism was a thing of Mars's distant past. But recent studies of this Cerberus Fosse mantling unit here, this ash deposit where we see an eruption happened right along here, and that happened not billions of years ago, not millions of years ago, but thousands of years ago. Geologically, that's recent. So volcanism could still be going on Mars even today. Now we see impact craters across Mars, but then we also see other types of holes. We see skylights, areas where we've had roofs of subterranean lava tubes collapse and expose these vast caverns beneath the surface, area where lava once flowed. Now, we know that there's no water flowing on the surface of Mars anymore, but again, there may be water flowing beneath the surface. And going down into some of these lava tubes would be really interesting places to look. Now, Mars has polar ice caps, much as the Earth does. And there's certainly water available there. We do not want to send our astronauts there, though. That is a really, really harsh environment. But we are going to need access to water. And fortunately, we've got it. Because on Mars, there are 2 mid-latitude bands of glaciers at about 40 degrees north and 40 degrees south. That's about the same latitude as like Washington, D.C., so we're not talking extreme polar environment here. And the amount of ice in these glaciers, if you were to spread that out, would cover the entire surface of the planet about 1.5 meters thick. So here we're looking down at one of those glaciers. This is a debris-covered glacier, a dust-covered glacier. So it doesn't shine gleaming white. But this is actually a good survival strategy if you're a glacier. You get that mantle of dirt and gravel on top, and that actually provides insulation, protects you from the sunlight. We see that here on Earth. I remember years ago, up in the Canadian Rockies, trekking out onto a debris-covered glacier there. And it was just all broken rock. You'd have no real way of knowing that you were on a glacier until we got to the very end of it, the edge where it was breaking off and calving into a lake. And as you looked over the edge, beneath this layer of dirt and rock, there was this shocking blue ice beneath us. Really cool. So we see those kind of debris-covered glaciers on Earth, and we see them here on Mars. And if you look, you see, I mean, if you've ever traveled to Alaska or seen pictures from Alaska, now this looks real familiar. We have these medial moraines. We have flow features. This is a classic valley glacier. This is a fun one. This is what we would here on Earth call a Piedmont glacier, where you have this toe of ice sticking out, flowing out between these mountains here. And we can zoom in closer to look at this big toe of glacial ice coming out. On Mars, we also have what we call lobate debris apron glaciers, these kind of low lens-shaped features that form around mountain peaks. We can see these glacial ridges here. And we can even see what we would call here on Earth a Bergschrund crevasse, where the ice is pulling away from the mountain face. Craters can be excellent places for glacial ice to collect. And in those, we can see these concentric fill glaciers. So one time just flying around Mars, using Mars Trek, I stumbled upon this. And this really caught my attention. I think this is really cool. There's all kinds of fun things you can find that will tell you stories. This impact crater here is a fine example of what we would call a rampart crater. Typically, when a crater forms on Mars or on the Moon, you get this big spray of pulverized, hot, dry rock. And these rays of material spreading out from the impact site. But sometimes, around craters on Mars, instead we see this thick, pasty deposit surrounding the crater. It almost looks like you took a rock and threw it into a mud puddle. And that's actually what we think happened here. We think this impact happened in an area that was rich in subsurface water ice. And so instead of getting this fine, dry spray of debris, we got this sploosh of mud. And if you look carefully, coming out from this pasty rampart blanket, you can see these dark fluvial features, these areas where water went flowing across the surface. And then later on, one of those lobate debris apron glaciers came rolling along and rolled right over the top of that ejecta blanket. So we know here that the glacier is younger than the impact because the glacier is overriding the impact blanket. So when you talk about something called a mega tsunami, you know you're in for something really cool. So Mars, again, once had an ocean, and that was early on in the history of Mars. At a time when the solar system was a very violent place, there were lots of impacts from lots of asteroids. And imagine an asteroid slamming down into the surface of an ocean. The result would be gigantic tsunamis, thousands of meters high, rushing hundreds of kilometers inland. And even though the ocean is gone today, here in the shorelines around the oceans, we can still to this day see the scars left behind by those giant tsunamis. We can see this kind of what we call thumbprinted terrain, where the turbulent water was rushing inland. And we can see the backflow channels where the water went flowing back, receding toward the ocean basin, and carved these pathways as it receded. We have a portal for the planet Mercury. And one of the features, or the amazing features of Mercury, is the Caloris Basin, the largest impact feature on Mercury, 1,500 kilometers across. And on the other side of the planet, we find this, an area that has been referred to as, and given the name of weird terrain. And it lives up to that name. It's all this jumble of strange, chaotic, what the heck is going on here? And people looked at this and they tried to figure out, what would cause the terrain to break up like this? And then finally someone noticed that this is exactly opposite the Caloris Basin impact site. So imagine that Caloris Basin impact, and you have a shock wave spreading out from it. And that shock wave spreads out and it goes all the way around the planet, and it focuses back in on the far side. And as that shock wave comes to a focus on the exact opposite side of the planet, it is like the most incredible earthquake you could imagine. It completely disrupted the surface of Mercury. We see a number of impact craters, but then we see other types of craters, irregularly shaped craters like these, volcanic pits surrounded by deposits of volcanic ash. Volcanoes on Mercury. This is cool stuff. As we look at a number of impact craters, we see these, what we call bright crater floor deposits. It's actually formed by a myriad of tiny little pits where, in the intense heat of Mercury, some of the minerals, some of the less resistant minerals, are actually turning to gas and boiling off into space. But even in this hot, hellish environment of Mercury, the closest planet to the sun, at the poles of Mercury, we again find permanently shadowed craters. And believe it or not, inside these craters, we find water ice. Ice on Mercury. We have a portal for the dwarf planet Ceres, orbiting between Mars and Jupiter. This world may be a refugee from the outer parts of the solar system. Its mantle is not made of silicate magma like we have here on Earth. Instead, it seems to be a slush of rock and salty water. Water plays the role of magma on Ceres. And where that salt water has erupted, the water can vaporize into space and leave behind deposits, bright deposits of salt on the ground. And there are volcanoes, cryovolcanoes, volcanoes of ice, like Ahuna Mons, standing 12,000 feet tall. The asteroid Vesta. There's some students here who have been studying Vesta in detail, students that are here visiting as part of our launch exhibition. Go see their poster. It's amazing stuff they're doing. But Vesta, one of the largest of the asteroids, was big enough when it formed that gravity would have pulled it into a nice, beautiful sphere. But if you look at Vesta now, it does not look like a nice, beautiful sphere. Okay, the top of it looks pretty good, but when you get down here toward the South Pole, it looks like something's missing. That's exactly the case. If we look straight down on the South Pole of Vesta, we see this giant 500-kilometer across impact crater, the Reyes Sylvia Basin, where 1 billion years ago, a smaller asteroid smashed into Vesta, almost destroyed Vesta. And if we look even more carefully, we can see that Reyes Sylvia overlies a similarly sized but more ancient impact crater. This is Venenia, 2 billion years old. So in the southern part of Vesta, it took 2 nearly lethal impacts. They nearly destroyed this entire world. And as you look around the circumference of Vesta, you see these fractures, these rifts, showing how Vesta was almost broken apart totally. We have some closer asteroids to us, some near-Earth asteroids. Asteroids that can actually cross Earth's orbit. These can be dangerous to us. And that's the whole motivation of the DART mission that is going to, fingers crossed, launch tonight. To protect ourselves from threats like these. We've actually recently visited 2 of these near-Earth asteroids. This is Bennu. And Bennu was visited by the OSIRIS-REx mission, which collected samples of material and is now bringing that back to us right now as we speak. And using the Bennu Trek portal, you can fly down to the actual site where OSIRIS-REx collected its sample. And we can even look around the surface and see some strange rocks that don't fit in. The rocks of Bennu are uniformly very dark, primitive rocks. But then here we see these light-colored boulders that stand out. And what are these? Well, a little bit of analysis showed that these are actually perfect matches for fragments of Vesta. So when Vesta got whacked so hard that it almost got broken apart, fragments of it went flying across space, and some of them landed here on Bennu. Another near-Earth asteroid that we've been tracking is Ryugu. And Ryugu was recently visited by Japan's Hayabusa 2 mission, which sampled the asteroid and it brought back, successfully returned, samples that are being studied right now. But you can go in using our Ryugu Trek portal and you can examine the data that was sent back by the Hayabusa 2 spacecraft. One of our newest portals is Europa Trek. And this examines one of Jupiter's moons, Europa. And as you look at Europa, you see a world that is completely covered in ice. And that doesn't sound very habitable. But it turns out beneath this global ice cap is an ocean of liquid water with about 2.5 times the volume of all of Earth's oceans combined. Now remember, here on Earth, wherever we find liquid water, we find life. With an ocean of liquid water that big, I would love to know what might be swimming down there. And we've got missions planned, including the Europa Clipper mission launching soon, to explore Europa in greater detail. We see these interesting fractures and chaotic terrain across the ice cap of Europa. And we're wondering if perhaps some of these areas might provide us access to be able to go down through that ice cap and start exploring the ocean underneath. You can see here how the surface has been broken into these ice rafts, and evidence that there is perhaps liquid water just beneath the surface. Look how this one block of ice here has been turned up on its edge. It's sticking down like this. This makes people think that that can't be just solid ice beneath. There's got to be something that it can rotate and sink down into. Saturn's largest moon, Titan, is unique in the solar system for having a dense, thick atmosphere, even thicker than the Earth's. Clouds cover a surface that actually has streams, rivers, lakes, and seas. But these are not seas of water, because the temperature is more than 200 degrees below zero. These are seas of ethane and methane, cooking gas, that at these low temperatures become a liquid. And so under these frigid exotic seas, we see chains of islands. But biologists are looking at this and they start to realize that they can come up with at least theoretical ways of how you could have conceivably, instead of water-based life like us, you could have hydrocarbon-based life. So could there be some alien form of life living in the seas of Titan? And Titan gets even more interesting because those seas are sitting on a crust that is made largely of water ice. And beneath that crust of water ice, we now have evidence that there is an ocean of liquid water. So perhaps on Titan, you could have two entirely different forms of life. Hydrocarbon-based life living on the surface, and water-based life like us living in an ocean of liquid water beneath. That makes this a pretty interesting sounding place. Our Icy Moon Treks portal allows you to explore 7 of Saturn's smaller icy moons. Enceladus is another ocean world. It is covered with a global ice cap, but at the South Pole there are fractures where we've actually seen water ice or water erupting from that subsurface ocean as geysers, water erupting out into space. We know it's there. We flew our Cassini spacecraft through it, kind of like driving through a car wash. So we know there is absolutely that there is an ocean of liquid water on Saturn's moon Enceladus. And here you can see the geysers erupting out of it. Dione is an interesting world with a different set of features. The leading side looks very different than the trailing side. Very rough, ancient, and cratered, resurfaced, strangely different trailing side. Rhea, again, has a dark and a light hemisphere. I'm not real sure what's going on there. Iapetus also has a dark and a light. But on one of them, the trailing hemisphere is light, and the other, the trailing hemisphere is dark. What's going on? We're not sure. Tethys clearly had a very bad day. This is Odysseus crater, and you can see that that almost took out Tethys. And here's Mimas with Herschel crater. I think Mimas does an excellent imitation of the Death Star from Star Wars. And here's Phoebe doing a great imitation of a wiffle ball. We think that this is actually a captured Kuiper Belt object from far, far out in the solar system. So these are some of the worlds that you can explore. Again, here's our Europa Trek portal, our Venus Trek portal. Ooh, Venus, this is our newest one. And this right here is an example of a large volcanic feature known as Artemis Corona. Venus it was just announced, we've got 2 new missions targeting Venus coming up in the future. So we're really excited about that. And if you go out in the evenings right now, just after sunset, look out to the west, you'll see blazingly bright in the sky the planet Venus, beckoning to us, just daring us to come visit. So again, I invite you to explore NASA's solar system treks at trek.nasa.gov. Thank you very much. Yes.